In number 1, it says use the diagram to help you find the volume of a right circular cylinder. And we're going to leave all of our answers in terms of pi. So the volume for any prism, and a cylinder is very similar to a prism because it's also connected by a rectangle, is base area times height. The base of this thing is a circle, and the area of a circle is pi times radius squared. So the base area is this, and we still have to times it by the height. The radius in this problem is 1, and the height is 1. 1 squared is 1, and 1 times 1 is 1, and 1 times pi is just pi. So this is really pi feet, or 3.14, but we're going to leave it in terms of pi, and it's cubed because it's volume, and volume is 3-dimensional. Number 2, it's the same idea, but because it's a cone, we need to cut it into pieces. So we would take that base area times height like we had from before, but because it comes to a point, we've cut off this side here and this side here, so it's a third of the base area times height. So we've got 1/3 pi times the radius, which is 2.8 squared, times the height, which is 4.3. And we're going to, again, leave these answers in terms of pi. So we have 2.8 times 2.8, and then times that by 4.3, and divide it by 3, which gives you approximately 11.24 pi centimeters cubed. If you did convert it to 3.14 for pi, it would come out to about 35.29 centimeters cubed. I prefer these types of answers because it's an exact, if it were not rounded, but this one works down here as well. In number 3, we're going to again find the volume of the cylinder, but here the radius is halfway. So instead of 12 squared, half of 12 is 6. So pi times radius squared times height. 6 times 6 is 36. And 36 times 17 is 612. And this is measured in millimeters cubed. And this one is also base area times height. But again, because we've cut off both of these pieces, we need to use 1/3 of that volume. So 1/3 times pi times radius squared times height. The radius in this problem is half of 14. 14 is our diameter. So we have 1/3 times pi times 7 squared, and our height is 18.2. So we're going to do 7 squared, which is 7 times 7, or 49. And then we're going to multiply that by 18.2. And then we're going to divide it by 3 and times it by pi. Which is about 933.42 inches cubed. The reason that I didn't change this one is because it came out to a funky decimal. But you could leave it in terms of pi, and it would be about 297.2 to 7 pi inches cubed. Number 5 has multiple steps here. We've got Oscar, who's filling a bucket that has a radius of 6 and a height of 12, and it's in the shape of a cylinder. And he has a shovel that has a radius of 3, a height of 4, and it is a cone. And it asks us how many scoops from his shovel will it take to fill that bucket. So we need to find the volume of each. Pi times radius squared times height. So for this one, we've got pi, 6 squared, and 12. 6 squared is 36, and 36 times 12 is 432, but we still have that pi. The units are inches cubed. Over here, for a cone, we need a third of that volume. So we've got 1/3 pi with 3 squared, and the height is 4. 3 squared is 9, and then we're going to multiply by 4, and then we've got to divide by 3 for this 1/3 over here, which is 12 pi inches cubed. To figure out how many it would take, we need to divide. So we're going to take the total volume that we need, and then we're going to divide it by how many each scoop is, and that will tell us how many scoops it will take. The pi's divide out here, so we can just do 432 divided by 12 to find out how many scoops it will take. And it will take 36 shovelfuls to fill the bucket.